The purpose of debugging. In this nugget, we're going to look at how to get those annoying bugs out of your script. We'll start by looking at the real purpose of debugging so that you can kind of understand the process that needs to go on in your head to make debugging as quick and pain-free as possible. We'll try and prevent bugs using a couple of techniques that are good for stopping simple types of syntax errors. And then we'll look at the two main debugging techniques that Windows PowerShell version 1 exposes: adding trace code and using the step debugger that's built right into the shell. So what is the purpose of debugging? And I don't mean just the simple purpose, which is obviously to get bugs out of your script. I mean more of the Zen philosophical purpose of debugging. Well, it's really twofold, and probably the best way to demonstrate it is to actually look at a script and see what it looks like. So I have this one here called Buggy, and as you might guess, it does have some bugs in it. Let's open it up in Notepad, though, and sort of explain what it's supposed to do. There's this function called concatenate, and that's where I'm calling it right here. And it's designed to take two halves of a file path and join them together into a single path. Now, as you can see, both of these end in well, this one ends and this one begins in a backslash, so we can't just jam those two strings together, or we'd have two backslashes in the middle. So it's designed to make sure that only one backslash winds up between each of the two file paths. So let's open up the Windows PowerShell window here, change to that folder, and run that script. And before it even does anything, it comes up with an error. Okay, well, this is one of the purposes of Windows PowerShell debugging, obviously, is to get rid of these errors. And what we're looking at here is actually called a syntax error, or a typo, if you want to be technical about it. And this type of thing is really common when you're working in Windows Notepad. All of this is just text sort of all strung together, and it's not even particularly easy to read. So that's why it's so important that you use a really good script editor. I'm using this free PowerGUI script editor, and it meets most other criteria for a good script editor. Notice this string here is color-coded, and this one is not color-coded, and that would be because that one is typed wrong. See, had I written the script in here to begin with, as I was typing, I would have noticed when the strig didn't turn into this teal color, and then it would have sort of called my attention to the fact that this is a typo. You might notice another one here where this part 2 is purple, and that part 2 isn't. And that's because I have another typo. I need to add a $sign to it. So that color coding is just one way it really helps. Another way is that as I start typing commands, it'll help me finish those commands. It'll also show me the syntax of the command. That helps prevent bugs in two ways. For one, if it is completing the command, there's not going to be any typo. And then if it's going to remind me of the syntax as well, then I'm less likely at least to make simple mistakes with the syntax. So now that I've gotten rid of these two simple syntax errors, I'm going to run this script again in the shell. And the result was C program files /:/ program files. So that's not what I expected. And here we come to the real Zen philosophy of debugging. Obviously, there's something wrong with my script. And I can only tell that because I'm not getting the output I expected. Now, I know that my input is okay. So if my input is good and the output is bad, well, then the difference is my script. Something in my script is wrong. And ultimately, the only reason scripts go bad is because there's something in a variable or something in an object property that isn't what you expected it to be. So ultimately, the goal of debugging is to get inside your script's head as it's running, to see your script actually executing and see what's inside every single variable, every single step of the way. At some point, some variable or object property is going to contain a value that's not what you wanted it to be, and that's the point where you've got the bug. So let's go ahead and close all of this out and just sort of set the stage. We'll open up a fresh Windows PowerShell window, change to that demo folder, and we'll run the buggy script. Okay, so that's what we've got. Good input, bad output. Something's going wrong in there. How do we figure out what it is? Well, it's important to note, first of all, that we're not getting any error messages. In other words, there's no syntax errors, there's no typos. PowerShell is able to read our script, it's able to understand everything we're telling it, and it's able to complete what we've asked it to do. We've just apparently asked it to do the wrong thing. So we've moved past syntax errors at this point. This is when we need to go back into the script and try and get inside of its head. There's a couple of ways to do this. Let me open this up in the script editor and get that going, but I'm going to switch back to the shell here real quick and introduce a commandlet called write debug. This is actually designed to spit out debugging information, not anything like internal to the shell, but debugging messages that you write. Things like this is a message. And when you hit enter, nothing comes up. Well, believe it or not, that's a feature. I want to take a look at the built-in variable drive, because on here somewhere there's a built-in variable called debug preference, and there it is. And by default, Windows PowerShell sets that to silently continue, which means anything that is output by write debug is suppressed by default. So we're going to change that. We're going to say debug preference equals continue. Now we're going to run that write debug again, and you can see that we get the debug output. To turn that off, we'll set debug preference equal to silently continue, which was the original default, and now our write debug output is suppressed again. So this is the key tool we're going to use to add trace code to our script. Let's go into the script here. The rule with trace code, or at least my rule, is this. Anytime the contents of a variable changes, or anytime the contents of an object property changes, output that information. So I'm going to say write debug, and in double quotes, and that's kind of important, I'm going to say $part1 equals $part1. Now remember that in double quotation marks, Windows PowerShell looks for that $sign to tell it this is a variable name, and it's going to replace that variable name with the variable's contents. I want it to do that the second time. That's going to allow me to see what's inside the variable part1. I don't want it to do it the first time, though. I want it to literally print $part1. So I'm going to escape that first $sign there. And I'm just going to copy this line to the clipboard, paste it again, and have it output part2. And anytime I change the contents of these variables, I'm going to do the same thing. So write debug, part1 is now part1. Oops, don't want to do that. Just want to copy this to clipboard, paste it in down here, and do the same thing because that's a line where part2 changed. So the other rule I have is that whenever I take a logical decision in a script, I want to write out some kind of debug information one way or the other. So here I'm testing to see if part1 ends with a backslash, or rather if not part1 ends with a backslash. If it doesn't end with a backslash, I'm concatenating a backslash and writing out the fact that I did it. In fact, let's make that clearer. Concatenated backslash, and now it'll display the contents of the variable. But if part1 already ended with a backslash, then these two lines of code would never execute. So I'm actually going to add an else that does nothing but alert me to that fact. Did not concat backslash. See, this way I get output from my script either way. I'm going to do the same thing down here. Started with backslash, else, write debug, didn't start with backslash. So now I'm able to get inside the head of my script. And the last thing I'm about to do is return the value from the function. And before I do that, let's just write debug again. About to return and we're going to say result. Now result doesn't currently contain anything, so here's what I'm going to do instead. $result equals part1 plus part2, and I'm going to return $result. This is also kind of my preferred way of doing things. Whatever you plan to return should go into a single variable all by itself. Don't return the result of an expression. Put that expression into a variable so that you can output it to debug, and return it, all using that single convenient variable. So now what's going on is I can see inside my script. I can see what's inside my variables every time they change. I can see every single logical path that my script takes, so I'll know which way these decisions went, no matter what way they go. I can see the final result that I'm returning. So let's save this and run it. Oh, let's see, it didn't print any debug information. Oh, right. Debugging is turned off by default. So at the top of my script, debug preference equals continue. Save it and run it again. Ah, look at that. Okay, now let's debug it. Okay, at the first part of my script, lines 8 and 9, part 1 equals C program files / and part 2 equals / Microsoft. Okay, that's what I expected, because right here is where I input that information into the function. Here's another trick with debugging. If you don't know what should be in those variables, then you won't know if your debug output is right or wrong. So before we look at the rest of the output, let's get an expectation for what should happen next. Does part 1 end with a /? Yes, it does. So I'm expecting to see did not concat / as my output, because this did not end with a /. So the next thing is, let's see, make sure part 2 doesn't start with a /. Well, it does start. So if part 2 starts with a /, then the next thing I'm going to expect to see is it started with a /. Let's go back to my output. Did not concat /. Well, that's what I expected. Started with a /. That's what I expected. Part 2 is now, oh wait a minute, part 2 is program files. See, before part 1 was Microsoft. How did program files get in there? Clearly something's wrong. And now, because I found the exact place where the script's execution differed from my expectation, I know exactly where to look. Let's see, my expectations were good here, and this decision was correctly executed because this was displayed, so the only other line of code that could possibly have gone wrong is right here. And if I look at this carefully, I'm setting part 2 equal to part 1 substring. I don't want to do that. I'm setting part 2 equal to this text. I wanted to set it equal to this text, so I need to change this to part 2. So it really was a typo, but it's not the type of typo that Windows PowerShell would recognize as an error. This is called a logic error. The script runs fine, it just doesn't do what I want. Let's save it, close this output window, and run it again. Hey look, I got the correct output this time. Part 1 contained what I expected, part 2 contained what I expected. It did not concatenate a / because it already had one. It started with a /, see right there? So it set part 2 to be just Microsoft without the /. That enabled it to concatenate the two together and have one / in the middle. So I've really made short work of debugging this by A, having a good expectation for what my script should do, and B, adding this trace information so that I can compare what the script is actually doing to my expectations. Now, just so that we can have some fun with this in another way, I'm going to put that one error back in and save my script. Now, one thing that you might think would bother you about this whole write debug business is now you've got to go through, now that the script is working, and take out all this write debug stuff. Not so. Just go to the top of your script and set debug preference to silently continue. Now when you run this, see, I'm still getting the bad output because I changed the typo back, but all the debug output went away because silently continue is suppressing write debug. That means my write debug statements are still in there for later when I actually may need to come back and change this script. And if my changes mess it up again, well, I can turn back on the debug output just by making that continue again. In fact, when I write a script, I add this write debug stuff as I go, as I'm writing the script for the first time, because I'm not confident enough that every script is going to be bug-free, so I figure, well, it's worth the investment to stick that information in there to start with, so that when I actually have a bug, all I have to do is turn on continue in debug preference, and I get all of my debug output right away. Now the next debugging technique is not going to utilize write debug. In fact, I left write debug disabled in my script. If we try and run the buggy script again, we get no debug output, and we're still getting the messed up output. Now, of course, we've figured out what that is now, but I want to show you another way you could have found that, and it's called Windows PowerShell's step debugger. To set it, I'm going to set ps debug step. Oops, set ps debug. Well, that's important to spell right. Now all I have to do is run my script again. Buggy. And what PowerShell is going to do now is prompt me before it does anything. So it said, okay, you asked me to run the script buggy. Do you want to run the script buggy? Yes. Okay, I'm on line 1 and it says to set debug preference to silently continue. Do you want to do that? Yes. Okay, I'm on line 3 and it's defining the function concatenate. And I'll give you a little tip right now. If you're going to use this step debugger, because it's showing you the line numbers, it's easier if you have a printout of your script sitting next to you. That way it's a little easier to kind of see what's coming up next. So let's go ahead and say yes. Let's define the function. Okay, we defined the function, but we didn't execute it yet. Now I'm on line 33. And incidentally, if you do have that printout, you're going to want a script editor that can print your script and put line numbers on it, because we just jumped ahead 30 lines. So if I don't have line numbers down the side of my sheet of paper, I'm going to have to sit there and count the lines, and jumping back and forth, it gets really difficult to do. Okay, so we're going to execute the concatenate function, and there's the input. So yes, let's execute that. Okay, do you want to continue with this operation? Line 8, yes. Line 9, yes. You know what? Let's stop right now. We're inside the function. Part 1 and part 2, those variables, should be equal to something. I'm going to take this option here to suspend the script. Suspend. Notice my prompt is different. It's got a couple extra angle brackets. I'm actually inside my script's head. For real. Look, part 1 has C program files. Part 2 has Microsoft. Okay, the next operation it's going to take on line 12 here is this not part 1 ends with backslash. You know what? Let's just get a preview of what that's going to be. Part 1 ends with backslash. Is true. So if I run the same operation that's in my script, false. So the result of this evaluation or this comparison is false. So I'm expecting the if construct to not execute whatever comes next, but instead to jump ahead to my else condition. So we're going to go back to the script by typing exit. Okay, we're on line 10. Do you want to execute it? Yes. All right, we skipped right over. So we're writing on line 16, did not concatenate the backslash. And you'll notice that it doesn't actually tell you it's executing the else statement. It just jumps into the first statement within that else block. Again, a lot easier if you can have your script sitting on a piece of paper next to you. So we'll go ahead and execute that. Okay, next, if part 2 starts with, all right, let's suspend. Does part 2 starts with backslash? See, by checking all these things manually, I'm not making any assumptions about what my script is doing. I'm sort of going alongside in parallel, and I'm doing the same thing the script is doing so that I can have an expectation. So the script is executing this operation. Oop, needs to spell it right. It's spelled right up here. Okay, it's spelled right up there. That's not a typo in the script. Okay, so the script evaluates this. It's going to get true. Therefore, I'm expecting it to execute whatever's inside the if block. So we'll exit. Yes, execute the if. Okay, we're on line 21. So it went inside the if block. It did what I expected it to do. So let's run line 21. Now I ran line 21 and that changed a variable. So it's time to suspend again and just make sure that that variable is what I think it should be. And it's not. That variable used to contain Microsoft, and this is where it got messed up, and now it contains program files instead. I only executed one line since everything was going good, so I know the problem is on line 21. I'm going to exit. This time there's no point in going any further. I found a problem, so I'm going to hit L for no to all, and that's going to tell me that we stopped the rest of the script from executing. I'm going to turn off the debugger because, here, watch this. If I just say, write output test. See, this debugger thing is kicking in even for ad hoc commands. So, yeah, execute that. And let's set ps debug -off. Yes, one last time, yes. Now I can run things like regular commands and they'll work okay because the debugger's off. But we had figured out that line 21 had the problem. So let's go back into the script, pull it up in my line numbering script editor, and on line 21, that was where my problem was. So now I can change it, fix it once and for all. So that's really two ways you've got to debug. You can add this trace output, or you can use the step debugger. Which you choose to use is really going to depend on exactly what type of script you're running and what type of problem you're running into. Sometimes writing that debug output is a little easier. Sometimes it takes longer to do the step debugger, but sometimes that's actually going to give you a little bit more control and a little bit more in-depth look at what's going on in the script. So you kind of have two techniques to work with. In this nugget, we've looked at the purpose of debugging, why we debug, and really the idea that debugging is about getting inside your script's head to find out what sort of data it's actually dealing with. We looked at some techniques for preventing syntax bugs, such as using a script editor that provides color coding and syntax completion and hinting. We looked at the write debug commandlet and how it can be used to add trace code to help you get inside your script's head and really see what's going on in there. We also looked at the step debugger that's built into Windows PowerShell and how that provides an alternative way of getting inside your script's head. Hopefully these things will help make debugging faster and easier for you so you'll get your scripts up and running just as quickly as you need to. I hope this has been informative for you, and I'd like to thank you for viewing.